So this being a talk about disasters, I want to point out that there are emergency exits on the front left and on the back to the left. Don't try to climb through the stairs because you'll be in trouble. There are also some photos and videos from previous disasters events, and they are here just to illustrate some points. This talk is about crisis informatics, and it comes from two different sources. One is the great work by the crisis computing team at QCRI, and the other is a book that's called Big Crisis Data, as this talk. Now, let me bring you to a sad event that happens in March 2016, where there was these attacks in Brussels. And I want to point out something very interesting that happens after those attacks. The police ask people to use social media, not phones. They ask people to refrain from streaming audio and video and to avoid reporting in real time about the police actions. Of course, this being the internet, in the first 8 hours after the attack, you had Wikipedia articles of hundreds of words, hundreds of YouTube videos per hour, Facebook pages, Facebook safety check, Reddit posts, tweets, photos, and a lot of material that was posted by people. And this corresponds to a common pattern that one observes during disasters. You have a disaster event or a mass convergence event. You have people who need to communicate more. You have people who are used to use social media as a communication means. And of course, the internet is not bulletproof, but it's very resilient. And moreover, emergency agencies ask people to use social media. And this brings that social media is actually very active during any disaster event for emergency communications. And this has attracted a lot of research from people from natural language processing to collaborative system, human-computer interaction, and so on that have been working on this topic for many years. Of course, the reflex of any data miner when you get like these big data sets is to try to classify, to cluster, to sort things into buckets, to order things by topics, by sources, and so on. And this is like the first thing we did. Like we did this study of Twitter during many crises, including some you may recognize, and observing that across different disaster situations you observe the same types of messages, but perhaps in different proportions, depending on a spatial and temporal characteristic of the disasters. There is also a very interesting temporal progression, where people in the first day after a disaster, they speak about cautionary advice, there are thoughts and prayers. On the second day, people start counting the cost and determining who was injured, who is dead, what was damaged. And on from the third day over, you see these donations and volunteering as something very important in crisis communications. So another thing that you can do if you like working with text is that you can extract different pieces from the messages and try to match people who are looking for something to donate and people who want to donate these things. Now, disaster events have a very strong geographical component. In this visualization done by Facebook, they show how people in Nepal label themselves as okay using Facebook safety check. And the people in blue are all their friends all over the world who saw this message and knew that their loved ones were okay. Now, what's interesting is that Facebook also allowed people to donate money to the Nepal relief efforts through their platform. These are the people who are shown in yellow here. And you see people all over the world that wanted to send money, to send donations to Nepal. And just as people donate money, they also donate work, and they volunteer work. And this has been a constant in many crisis situations where you observe people doing community-powered mapping from Libya to Syria through a large set of volunteer and technical communities. Now, in addition to mapping disasters, you can also do other types of community mapping. For instance, there is an experiment we did with some people that are UAV enthusiasts, and they were taking these photos and videos in a national park where we ask volunteers to label these images whenever they found an animal in order to train a machine learning system to be able to count animals automatically using these photos. You see also a lot of effort in automatic mapping in Europe and Brazil and in other places, and of course some efforts on doing hybrid mapping, mixing machine intelligence and human intelligence and compassion to try to mine this data in real time. Now, I believe some interesting, and I think that the future is in these real-time crowdsourcing mining applications, where you can mix stream processing and crowdsourcing in the same application. Let me show you one example of that. Imagine you have a disaster area, such as Vanuatu after this typhoon, and you fly a UAV, and you ask volunteers to label whenever they see that there is some infrastructure that is damaged, like a rooftop that is gone, or any infrastructure that is damaged. And here you see these volunteers are clicking whenever they see some infrastructure damage, and given that we know where is the UAV and in which direction it's looking, we can automatically try to create this map by aggregating the clicks from the user. So this is something that traditionally will take maybe 2 weeks to create like a very detailed map of an area. And here you can see how in a local area, in perhaps 15 minutes, by the time the UAV has landed, you already know more or less which are the parts that require more attention. Now, let me finish with one slide where I claim that in this space, a good project has to be something that is computationally feasible, that is supported by the data, and that is useful. I think most of the work I have done falls actually here, like in things that are, you have the data and you have the technologies, then you go and do whatever you do. I've been privileged to be able to target occasionally this dot, and I invite you to try to do the same in your work. And with that, I say thank you. Thank you very much.